Hello algebra students. Today let's cover section 8.2, simplifying radical expressions. By the end of this section you will be able to use the product property to simplify radical expressions and to use the quotient property to simplify radical expressions. Let's start with the product property of nth roots. If the square root of, or the nth root of a and the nth root of b are real numbers, and n is greater than or equal to 2, meaning that it's a square root, cube root, fourth root, something at least a square root is an integer, then we can split the square root of ab into the nth root of a and the nth root of b. And vice versa, the other direction, you get this. All right. For the first example, we want to simplify the radical. And so how we want to do this is split 75 into something that I can take the square root of. And so if I were to factor 75, the factors of 75 are 3 and 25 is 5 times 5. So the prime factorization of 75 is this, and since there are two 5s, a 5 can come out. So we want to split this into the square root of 3 times the square root of 25 because I can take the square root of 25. Okay, so I'll write that as the square root of 25 times 3, the square root of 25 times the square root of 3 is equal to 5 square roots of 3. For b, I can see that 891 is divisible by 9. And then 99 is divisible by 9. And then we can split the 9s, but instead I'll just put them together as 81. Okay, let's just hold that in our head for a minute. So if 9 times 9 times 11 is 891, then I could write that as 81 times 11. And the square root of 81, I know, is 9. So that is equal to 9 square roots of 11. All right, can you do that for letter C? For the cube root of 54, I want to make a factor tree. So 54 is 6 times 9, and 6 is 2 times 3, and 9 is 3 times 3. So since it's a cube root of 54, I need to take out 3 numbers. So what is 3 times 3 times 3? It's going to be 27. So 54 is the same as 2 times 27, and the cubed root of 27 is 3. So that is equal to 3 cube roots. Oops. Cubed roots of 2. For the fourth root of 80, we're going to have to take out 4 things. So let's just do our factor tree here. We can do 2 and 40, 2 and 20, 2 and 10, 2 and 5. So here you can see that we have 4 2s that are going to come out, and then we have a 5 that stays in. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 80 is 5 times 16, or 16 times 5. So I'm just going to change the order of that since I wrote it in the wrong order for it to work. We're going to take the fourth root of 16 times the fourth root of 5. So the fourth root of 16 is 2. So we have 2 fourth roots of 5 as our answer. All right, let's do a factor tree for 64. 64 is 2 and 32, 2 and 16, and then 16 is 4 and 4, which is 2, 2 and 2. So we need 5 to come out, 5 of the same number. 1, 2, 3, 4, 5, which leaves 1 inside the fifth root. 2 times 2 is 4, 2 times 2 is 8, 16, 32. So this is equal to 32 times 2, the fifth root. So the fifth root of 32 times the fifth root of 2, and this becomes 2 fifth roots of 2. So you don't always have to make a factor tree, and you don't always have to write the second step. I'm just doing that to show you the process here. Let's move on to the next part, where we have variables. For this section, it says simplify each radical and do not forget to use absolute value signs as needed. I'm not sure that we're going to need them yet, but in case. All right, so the square root of 4y is the same as the square root of 4 times the square root of y. I can take the square root of 4. The square root of 4 is 2, but we can't take the square root of y. So that's as far as it simplifies. I can take the square root of 196, and I can take the square root of y squared. So we'll write it as the square root of 196 and the square root of y squared. Now when I take the square root of 196, I get 14, and when I take the square root of y squared, I get y. And in my key, it doesn't say that that's an absolute value, but I feel like it would be because it was an even root and we got an odd. We'll just leave it. We won't worry about the absolute values for now. For C, I want you to try that one, and then we'll come back. Right. And I'm looking at my revised notes, and they actually say that we don't need to worry about the absolute values, so let's just cross this out. We're going to assume that all variables represent non-negative real numbers. So assume all variables represent non-negative real numbers. Okay, so we're not going to worry about the absolute values for now. Moving on to D. This is the same as the square root of 3 and the square root of y to the 8th. We're going to divide 8 by 2 so that we get y to the 4th. And then the square root of 3 stays the square root of 3 because we can't take the square root of 3 and get something that's rational. It would be an irrational number. All right, square root of 18, I'm going to write that as the square root of 9, a squared times 2a. And let's think about that. So the 9 times 2 gives us 18, but I know that I can take the square root of 9. And then for a to the third, I know I can take the square root of a squared. So that's why we put this separate. And then to get 18, we multiply by 2 and a to get a to the third. All right, So square root of 9a squared is 3a, but 2a needs to stay inside the radical. I want you to work on f in your groups as well as g. So for f, you want to take the cubed root of 125 and the cube root of w squared. And the cube root of 125 is 5, because 5 times 5 times 5 is 125. But the cube root of w squared does not simplify. For g, we have a square root of 20. 20 is 4 times 5, and x cubed is x squared times x. And I'm going to leave it like that because the 4 and the x squareds I can take the square root of. So I'm going to have the square root of 4x squared times the square root of 5x. The 4x squared becomes just 2x because we take the square root. The 5x cannot be simplified, so we leave it as a radical. For h, let's think about this in our groups as well as I, and I'll be coming around to help your groups. Now that we've completed these examples, I want you to put a little note on the side of your page that says when taking the nth root, we divide. When taking the nth root, divide the exponent by n, or of the variable, the exponent of the variable by n. When taking the nth root, divide the exponent of the variable by n, and turn your page when you're ready. The quotient property of radical expressions says that if the nth root of a and the nth root of b are real numbers, and b cannot equal 0, and for any integer n that's greater than or equal to 2, then the nth root of a over b is equal to the nth root of a over the nth root of b, and vice versa. So we're going to simplify these radicals, and it says do not forget to use the absolute value signs as needed. But we're actually not going to worry about that, so we're just going to cross that out. Because we're going to assume that it's non-negative. Okay. Let's split this into the fifth root of w to the fifth and the fifth root of w to the second, because 5 plus 2 is 7. Therefore, we can simplify the first part. The fifth root of w to the fifth is just w, leaving us with the fifth root of w squared. For b, we can split this into the square root of 36 over the square root of 121, which gives us 6 over 11. Same thing for c. Let you guys think that one through. And then for d, so you go ahead and write your answer for c. For d, it's a little different. We're going to put everything together to simplify it. So 15 divided by 3 can go into one radical, square root, and that simplifies to just the square root of 5. We couldn't simplify it before when it was square root of 15 over square root of 3, so we'll just combine them into one radical, and it's a little more simplified to just be the square root of 5. Okay, then we have the cube root of b over the cube root of 125. We cannot simplify the numerator, so that's just the cube root of b, but the denominator, the cube root of 125, is 5. So that's how that simplifies. Can you try F and G in your groups? And then we'll come back for H and I. Go ahead and check your answers, and let's do H. So we have the cube root of x to the 5th and the cube root of 8. In the cube root of x to the 5th, 3 can come out with leaving 2 inside. So that would be like this. X to the 3rd and the cube root of x to the 2nd. Then we have the cube root of 8, which is just 2. We'll just simplify that right now. And the cube root of x cubed is just x. So then we have x cubed roots of x squared over 2. And for I, I'd like you to do I together, and then we'll talk about it as you're working on it. Let's do these last two examples. I know that it's really tempting to try to cancel these 4s. You have shown me that you really want to do that, but if you leave my class with learning one thing, do not cancel things when they're being added or subtracted in a numerator and denominator. Okay, that's not a factor. You cannot do it. All right, so let's see how we can simplify this. And then I'll let you work on B together with your groups. All right, so we have 4 minus the square root of 12 is the same as the square root of 4 times the square root of 3. So then we have this. We can take the square root of 4, so that we get 4 minus 2 square roots of 3 over 4. And I believe that's as far as we can simplify this, because we can't cancel those 4s. All right, there is actually one more thing we could do. So we can factor out from this a 2. So we have to divide each piece of that by 2. So 4 divided by 2 is 2 minus the square root of 3, right? Because if I were to redistribute this, I would come back to the original 4 minus 2 square roots of 3. Okay? And then, after we factor that out, we can have the 4 in the denominator. And the 2 and the 4 are factors because they're being, the 4, it's not being multiplied by anything, but it's not being added either. The 2, we're not adding or subtracting it to anything, we're multiplying it. That's the only reason we can cancel these now. We could not cancel them back in the beginning. You would have gotten a different answer. So the 2 becomes a 1, the 4 becomes a 2, and we're left with 2 minus the square root of 3. That's as far as that goes. We cannot cancel those 2's. Okay, there's nothing left to factor out. All right, go ahead and work on B and see if you can simplify that further for question B. Did your group get 3 minus the square root of 5? I hope so. Now I want you to work on your summary. So think about 1 or 2 things that you want to remember from today's lesson. Write those down and then share one of them with a group member. So give one, get one, and then write down one of their thoughts into your summary. And your homework is here, so you can go ahead and head your homework paper, put the heading on it. And I hope you have a great day.